fault zones. My name is Sajida Fhamy. I am the General Secretary for KEAN. Professionally, I'm a Senior Safety Director for the MTA in New York City. I'm so excited to have you all join us today for our Engineers Week 2025 celebration. The theme is Design for the Future. We have an amazing lineup of panelists to discuss this theme. They are some of the top experts from India and the US. Some of the goals for today's panel discussion is to discover some cutting-edge advancements in shaping the future, gain some career insights from these industry leaders, and last but not least, to be part of a global movement in engineering and innovation. But before we start, just wanted to provide some general housekeeping rules. One is kindly mute all your microphones. We are also requesting everyone to turn off your cameras except for the speakers. And lastly, there will be a 10-minute Q&A session in the end. Please feel free to add your questions to the chat box. Our moderators will be monitoring the chat box. You can also ask questions by unmuting during the Q&A session. Feel free to turn your camera on when asking those questions. So without further delay, join me in welcoming our amazing panelists. We are going to go in the following order, starting with Mr. Praveen Krishna, followed by Mr. Anurag Srivastava, followed by Ms. Noorie Rajvanshi, and then Mr. Shashank Tamaskar. So Mr. Praveen, please take it away. The floor is yours.
Thank you, Saima. Good morning, good afternoon, and good evening to one and all. So I hope you can see me and my voice is clear. So let me just share a brief about my organization, and then, we'll start. I hope, can you see the slide?
No.
Okay.
It was showing up. I think you may have to do it again.
Yeah.
Oh, okay. So let me just, oh, it was going out. I hope I have the permission. Is it visible now? I hope I can make it as a full screen. Yeah, I think. Oops. Yeah, I think now this is.
Yeah, this
visible.
is good. Yeah.
All right. So let me just, before introducing myself, let me introduce my institute. What you're seeing on my screen is actually an institute which is started in 2007, called the Indian Institute of Space Science and Technology, which is primarily focusing on the research, development, and one of the prime motives for us was to supply quality manpower to Indian Space Research Organization, because all of you are aware at certain point of time, because of the software boom, we were having a serious shortage of manpower talent working in engineering areas, and especially there was no new joinees coming into the Indian space sector. So at that point of time, under the leadership of Sri Madhavan Nair, the chairman of ISRO, and along with Dr. Manmohan Singh, took a decision to start an institute which basically supply manpower to the Indian Space Research Organization. So with that mandate, we started to supply manpower to ISRO, and I can proudly say that around 1,560 of ISRO's scientist engineers out of the 12,000, 6,000, 8,000 people belongs to our institute. So some of them are now moved into the mid-management level. So that is actually the impact of this institute on the Indian space industry. And we do have three basic branches which what you call it as supply address to the needs of the country, especially in space exploration. We have aerospace engineering currently admitting around 72 students, followed by earlier it was called an avionics department. Now we call it as the electronic and the department is still avionics, but we give 72 electronics and communication engineers, basically on navigation, guidance, stuff for the space applications. And then on the satellite application, on engineering physics students, basically focusing on the applications of satellite systems, something called the Earth and Space Sciences. A lot of them works on the applications of the space. So we do have programs on masters. In aerospace, we have 3, another 11 more in avionics, and then totally around 15 masters programs, totaling up to something like 150, 200 people as postgraduate students. The entire institute, the faculty is on research and postdoctoral positions. So we have almost more than 300, 400 people registered for PhD graduates. And some of them are ISRO scientists doing, PhD under our department. So with that, I'll just get into the my profile, and I did my master's and PhD in IIT Madras, basically in the area of mechanisms. And BTech, as Sindhu was earlier telling, I was doing BTech from mechanical engineering. Currently, I am an associate professor in aerospace engineering. And earlier, I worked in General Electric as in different roles. And then I moved on to Honeywell as a turbocharger specialist and bearing specialist, and then moved back to IIST as a faculty in 2013. I fundamentally work in areas of fluid structure interaction, noise, vibration, harshness, nonlinear dynamics, and that is what my area. I do certain projects for the Indian Defense Organization, basically gas turbine research establishment on some of the gear designs, and then I do work some projects with DST, and that's all about me. And I think maybe I can just close the share, and then maybe I can go to the topic of today's discussion, right? So let me just stop sharing and then get on so that we will have certain memory free for the stuff. Okay, so I would like to take the topic in 2 different ways. The first one is basically on the global perspectives of the aerospace future, and then what exactly India's specific views. So this itself, aerospace itself, we can classify basically into 2 factors. One is the aeronautics, where see the transport, airports, transports, and so on, and then comes to the aerospace, which typically I think that is what the focus today is. But when we look at very India specific, this aeroplanes or the aircraft making an industry is still a challenge, because we do not have many of the indigenous commercial aeroplane making in this country, nor the aircraft engines either. So one of the greatest challenge which India is going to face in the subsequent years is basically on how good we are going to make the manufacture the commercial for transport aircrafts, because we do have military aircraft, the light combat air vehicle, LCA, but we do not have the commercial airplanes other than one prototype which is developed by NAL. So that is one of the key challenges when we look at India per se on the manufacturing sector of the commercial airplanes. And if you look at, again, comparing to the global perspectives of the aircraft industry or aerospace industry, If you look at the aerospace transport, the mode of transport, air mode of transport in the global, almost all the developed economy is saturated. But India is just slowly taking it up. If you look at that, India government is having a plan to open 50 airports, not basically on the big cities, because on the what you call as the satellite cities, they are going to open up another 50 more airports. And, that really means that in terms of economy, that means a lot, because you need to have infrastructure, you need to make sure that airports, you need to have the aircraft maintenance, you need to have the ground staff, you need to have people who are supplying to this. So it actually means a lot to a country like India, where the moment when we are going to have smaller cities getting airports, and the transport is the air mode of transport is going to build up. So it actually opens up a hell a lot of opportunities for the Indian aerospace graduates, as well as the companies which work in India on aerospace manufacturing. Now, again, if you look at from 2014 onwards, from a perspective, which I can really say that some of our alumni are part of this, making the aerospace start building, like Boeing, Airbus, Cessna, all these big commercial aircraft manufacturers and helicopter manufacturers, helicopter company. They do have their either one of their design wings or their, I think Airbus has actually, they have factory which they put over here in India. So some of the aircraft components are being manufactured from this place. So if you look at on the aerospace manufacturing plus aerospace technology development, obviously the current state of the art on 2025, India is going to see a lot onto the fabrications, and we are going to see a lot of demands coming. Coming into the aircraft engine part, I think recently the government of India and HAL has actually signed an agreement with GE 404 for supplying engines to the LCA program. And it is not just supplying engines. They are going to have an agreement with HAL to manufacture the engines over there in HAL factory. So the current technology is being transferred to India as well. So if I just look at from that perspective, the aerospace in aeronautical travel is still again booming in India. So that you can see some of the academic institutions in India, you can see the number of faculty they are being recruited on the aerospace industry is still going to be very high. IIT Madras has more than 60 faculty now going to work on aerospace department, which is as strong as that of an earlier mechanical engineering. Now, coming into again on the air mode of transport, just ping me if I am overtaking the time. So there are very specific problems in India which we need to really address. The traffic congested cities. So there are people seriously working on air taxis, and some of the air taxis have actually, the prototypes has been developed. And some of the academicians are actually actively involved in it. And this is something which is very specific to India, because if you just get into Bangalore, you take almost the same time. You are traveling to some other place, 3 hours, 4 hours of traffic walk. So this kind of air mobility, which we call it as the e-plane or the e-taxi or whatever it is, so that is seriously going to change the picture of the aerospace thing in India. Another coming 30, 40. I'll stop over there in the aircraft, and I'll get into the space industry per se, which is currently in India, it is actually a monopoly of the government, but this government is very proactive in making sure that the space sector is actually open up for the private players. And that is actually a very favoring situation for the future of the aerospace graduates. A lot of our alumni are in almost all the space startups in India, for example, either the Skyroot or the Bellatrix. So you can see at least one of the IASTNs are actually working on these industries. Again, compared to on a global scale, the 10 years ago, if you look at the way a satellite, a kg of mass, if you want to put on the space, the price was almost like 12,000 K or 20,000 K dollars per kg of satellite. But now that has come down to such an extent of it's more than approximately around 300, 400 K because of no SpaceX. If you look at this, why exactly this difference has come? Early 1990s, the US has opened up the space sector for private players, but see, it took almost 20-25 years for private parties to just build the technology, make it, and open to work. And India, we started very recently, but sure that in another 20-40 years, our smart engineers will make sure that the startups or the private industry in India is also going to come up with excellent type of propulsions or small satellites or whatever it is. As an academic institute, we do our share on that. See, our institute is one part where the institute, we have a small satellite design section. We actually make small satellites, basically CubeSats of different sizes with different universities across the world, pan Europe as well as US together. And then we do have a satellite, maybe only one academic institutions where we have the satellite tracking station, where we have a small ground station where we'll be able to communicate with satellites and get data out. So this is again, if you look at the what you call the global strategy with the Indian space strategy, the Indian space program is always focused on making sure that our growth is focused towards the development for, I don't know whether you guys are aware of the sustainable goals of the UN. So there are 14 of them which has been actually mandated by the government of India onto the space sector, which includes for the flood prediction, for geographic things, uplifting the poor. So actually, all the satellite programs of the Indian Space Research Organization is actually tuned when we use the taxpayers' money, which we make sure that we are suited towards the sustainability goals. And along with that, now we are also getting into a spacefaring station. There are plans where we are going to come up with something like an international space station, and then there is a moon's mission, Mars mission, and so on has been planned. So I am sure that the space industry, which is over here in India, is going to seriously see a growth in the coming 10 to 15 years. I think that introduction, I'll just stop this over here, and then maybe I'll just put a closure remark. And I hope this is 22nd is actually George Washington's birthday, and which is the reason why we celebrate Engineers Week. So I just say a visionary leader to my pranams, and then I'll just close over here. I think I have not overshoot the time. I think it is just on time. So if I have more time, please let me know. But otherwise, I'll try to say a closure.
Thank you, Praveen. We are good on time. So we can move on to the next panelist.
Yep. Thank you.
Thank you so much.
If anyone have any question, just put it in the chat so we can take it at the end of all the panelists' presentation. Sajid, go ahead.
Next, we have Mr. Anurag Srivastava.
All right, thank you. So let me just share my slides. You can see it okay?
Yes, we can. Thank you.
All right. Well, so I work at West Virginia University as a professor and also a department chair. I also have a adjunct professor appointment at Washington State University, and I also work as a joint appointment with Pacific Northwest National Lab as a senior scientist. So I work in the power grid area and research and applying AI and especially enabling the cyber resilience of the power grid and weather resilience of the power grid. In the past, I've been working on this more than 20 years. So I got my PhD from Chicago in 2005, and then I spent a lot of time at different institutions as a visiting position. So I worked at MIT for a few months, in Aachen University, at Idaho National Lab for almost like 9 months. P&L is still working on. I spent a few months at PJM working and understanding their market system, which is one of the grid, operator. I spent some time at GE for a few months, and then I also worked at France, a French grid operator, which is RTE. I spent some time and help developing software at SEL, Soil Engineering Lab, for the synchrophager and assessing and validation. I was assistant research professor at Mississippi State University. And then I also worked at Peak Reliability, which is another grid operator on the western side, just like PJM is on the eastern side of USA. I spent almost 11 years at Washington State University and before moving to West Virginia University, and I still have adjunct appointment because there are some PhD students that I am working with them. And of course, West Virginia University is here. Over the time and over several years, I, other than being professor, which is teaching and mentoring students, I also worked on a lot of research projects and transitioning into industry. One of the biggest projects was this US-India collaborative project for distribution grid with energy storage, and that's a 30 million project where DST, Department of Science and Technology, and US DOE, Department of Energy, worked together. It was a large team. I was a technical lead for this whole project, and that resulted into a lot of different outcome, which, of course, I'm proud of. I also set up a lot of different center, and helped as a core team member. One of that is AGI, Advanced Grid Institute, which is with PNL and Washington State, which I'm still a part of. All right, so with that, let me quickly go through something that we all work with, right? So critical infrastructure is all around us, right? Either you're using cell phone or you're using the public transport or going to the hospital for healthcare. IT, either defense industry. So this is all around us that we have. And one thing that drives all of these is energy systems, right? And energy system is really broad term, which is any energy, which is electrical energy is one of the, one of the energy systems, which is power grid. But we also have, gas network, which is helping us to generate energy, right? And these energy, is without that, we cannot operate. Like Earth will not have all the resources to do things that we want. So if you want to do something, imagine a world where energy is abundant, secure, and intelligently managed, but also under constant threats that we know, either it's weather impact or it's cyber threats. None of these is true, which means that we are not having abundant energy. We are still trying to find more efficient and more resources so we can run our need for energy. It's not secure. It has been attacked. Ukraine was attacked in 2015 and 16, resulting in the power outage. And weather impact we keep on seeing on the power grid a lot, right? So what we can do, the biggest threat is weather and then cyber attack. Cyber attack is more challenging because it's invisible. Attacker is trying to, basically hiding themselves. And now AI is of course helping us, but also AI is helping the attacker. They can find the new attack threat vector through AI-driven adversaries. This is a very busy slide. I don't want you to go through all these, but I'm just trying to say that even the cybersecurity is so vast, and so much problem and challenges can be solved for each of these, right? So, on the top that you see, which is basically showing the HMI, is a human machine interface. Actually, typically, that becomes one of the gate or open door that allows the attacker to get into the power grid OT system, which is operational technology. Right, ICS industrial control system, PLC is another controller that is there. Each of these we can spend years and years to solve just the cybersecurity problem, right? But what is important is that we only know few things about cybersecurity vulnerability, which is these 282,000 vulnerability exposure that we have discovered. There are several unknown. But the digital footprint in our world is just keep increasing. Just think about 376 billion email sent every day and received, which becomes one of the hook for the attacker also. So we definitely need some cyber warriors who can understand this landscape, which is very vast, and help and support this, right? AI is a game changer, another game changer that we are seeing all around us. Either it's supervised, unsupervised, all these different things. How do we use that to design, different software and hardware, which will help us to get where we want to, right? And I think which is very important is the human machine interface, because together they are the one who are solving the system level problem. And we know that at this time, somewhere humans' brain are much better if it's a complex, while if it's a repeatable task, then machine works better. How do we get and design a machine and collaborate with human to do more is definitely one of the things, right? We do need several minds to work together to make it robust, ethical, and efficient. How does future look like? We keep hearing about a lot of these new approaches and things that are coming. As an engineer, which is a physical system that I deal with, for me, it's physics informed AI is important, because just the machine will not make sense unless it is following the physics principle, right? And there are so many more things like quantum resistant security, which I've been trying to work on. Neurosymbolic AI powered threat hunting, that will help us. Blockchain for cybersecurity, energy training, human AI collaboration is of course very, very important. There are a lot of things that getting designed, like, just last week, this a clone was launched. Google has this AI co-assistant. And last week also, Microsoft announced this quantum computing chip. So a lot of things are happening. What is needed is an interdisciplinary approach, right? So if I ask you this question, what is the similarity between snowflakes, cauliflower, and your brain? It might be hard. You can answer later. But one thing that is common between all is that small things repeat itself to make the big things. If you look at this, the small thing, which is being repeated and making the complete system, including human brain, which is the most complex thing that we ever know, it is called fractal. So fractal is a mathematical concept, and this can be applied to so many different things because it is around us. It is in flower, it is in snowflakes, it is in mountains, and we can apply these kind of mathematical concept to make the world better. Finally, let me leave you with thought that every research, every design start with the question, and then sub question, which will narrow this, right? So it's all about what problem you will solve. And then lifelong learning is really, really important. So I'll stop here, and maybe can answer some question later.
Thank you so much, Mr. Anurag. That was great. Great information from Mr. Praveen and Mr. Anurag so far. Next, we're going to go to Ms. Noorie Rajwanshi.
Thank you. Going to share my screen. All right. Thanks, everybody. And thanks for inviting me. Today, I apologize in advance if I take a break to cough or my voice is real hoarse because I'm just recovering from a cold. So I am going to spend a few minutes talking about my background and my work here at Hewlett-Packard Enterprise. So maybe let's start with a background. Currently I am a technical sustainability lead. Excuse me. With Hewlett-Packard Enterprise. You might have heard of HP. HP split in 2015 into Hewlett-Packard Enterprise, which is an enterprise company. We make servers, networking solutions, storage solutions, etc. And HP Inc. is now a laptop and printer company that you might be more aware of. I work in our operations sustainability team and lead our technical sustainability work. So what I essentially do is focus on embedded carbon in our products and solutions and figure out how to measure this carbon, how to report it, and then eventually how to reduce this carbon. So all of my work is focused around these three topics. It could mean our own manufacturing, our supply chain, our logistics, how our products are moved, etc. And I'll talk about a little bit about that in a minute. But before that, a little bit about my background. I have a bachelor's, master's, and PhD in mechanical engineering. And during my PhD, I focused a lot on environmental engineering. So I have a minor in environmental engineering as well. I discovered that I wanted to remain into core engineering, but also focus on sustainability. And for that, life cycle assessment was a methodology I found which would help me quantify the environmental impacts of the products and solutions that we are building. And until you're able to measure, you don't know what the hotspots are. And as the engineering brain works, you want to figure out where the problem is so you can solve it in the most effective way. And I'll talk a little bit about what LCA and product carbon footprint is in my next slide. After my PhD, I continued on and did a postdoctoral research assistantship at Columbia University, where I looked at silicon photovoltaics and how their environmental impact, where their environmental impact is coming from. And then I joined Siemens, where I spent almost all of my career until I moved to HP recently. So at Siemens, I started as a life cycle assessment engineer, looking at our products and solutions, looking at where we can make a change in the design of the products Siemens makes to make them more environmentally friendly, sustainable, as well as not compromising on economics of it, right? I mean, I worked at corporations, so their goal will continue to be making money, right? So we have to make sure that we are decoupling environmental and economic impacts to have this sustainable development growth. At Siemens, I also worked in our urban development group, where I worked with a lot of cities in North America, looking at the environmental impact of cities and how they are planning on reducing their greenhouse gas emissions and how technology can help them achieve the reduction in greenhouse gas emissions. Excuse me. On my as side projects, as passion projects, I have also been co-authors or chapter authors in a couple of books. One of them very well known called Drawdown. It was a New York Times bestseller list for a very long time. It provides 80 of the top solutions that can help us create a drawdown of carbon in the environment over the next several years. And another book I contributed to called The Climate City. The chapter is a smart city, so focusing on how building a smart city doesn't have to compromise on the environmental benefits that it can bring. Now, just a few few slides to focus on my work at HPE. So at HPE, I so just to give you a background what HPE does, as I mentioned, HPE makes everything from really large supercomputers. So the world's top 9, the fastest 9 supercomputers currently are made by HPE. Many of them, most of them are actually in US national labs. We also make servers in data centers. We make data storage and networking solutions, as well as many software and services. So everything that is going to take us to in the journey of AI, we have those solutions in enterprise level. And I put our carbon footprint right next to the list of these solutions to show you that we are trying to measure everything we are doing, right? So currently, you see our carbon footprint. Only about 2% lies in our own hands, right? Only 2% is within our own operations. Most of our carbon footprint lies outside, right? So 32% lies in our supply chain. So the products that we purchase, the products, how we move them, how we are producing upstream energy, etc. And then the major portion of our carbon footprint, about 66%, lies in our product use. So once the product leaves our factory doors and it makes its way to the customer's location, it's going to live for a very long time. And throughout its lifetime, it's going to use energy, electricity mostly. And then it is going to have to be disposed of. So the end of life and the product use are responsible for 66% of our own footprint. So as I mentioned, company-wide, we have really ambitious goals to reduce this carbon, not just what we are responsible for, but what is in our supply chain upstream and downstream as well. And in order to do that, what we have to do is we need to measure accurately. I mean, there are many ways of measuring it, right? Starting from a level that is taking it at a revenue-based allocation, and then going into more accurate measurements based on product material and process data. And then eventually we want to provide every single of our customers free access to accurate and credible measurement of this product carbon footprint reports. And then hopefully this will help us pinpoint where we can reduce our emissions. And then this is my second last slide. I want to explain what a product carbon footprint is. So I'm not only interested in the use phase carbon emissions, even though it is a big chunk of our emissions. I'm also interested in the embedded carbon within our products. So where do we source our raw materials? How do we manufacture it? How do we transport it? And how do we dispose it, right? So I need to be able to measure every single step of the way the carbon that is embedded. And then finally, what I mean by having accurate report for our customers or any stakeholder who's interested in learning about carbon footprint is a report like this, where they'll be able to see where the carbon emission is coming from within a product's life cycle. They'll be able to configure the products, making different choices to see how they can reduce the carbon footprint. And then for us, our designers can look at the hotspots and make design choices based on that. So I'm going to stop sharing, and that's I see there are a lot of questions in there, but I guess we'll take them towards the end of the.
Thank you so much. Thank you, Noorie. That was amazing. Great information. I'm learning a lot. And special thank you to you for making it out here when you're not feeling well and coming out and supporting us. So next we have Mr. Shashank.
All right, let me share my screen. Just give me 1 second. All right, so my topic is called Plowing with Pixels. So I want to inspire in the next maybe 10 minutes or so that why focusing on agriculture is the right choice for sustainable future, right? So before we go into that, I'll tell you a little bit about myself. So my name is Shashank Tamaskar. I did my BTech BTech in Aerospace Engineering from IIT Bombay. When I was at IIT, I built a student satellite along with a group of students that was launched by ISRO in 2016. Then that inspired me to pursue aerospace engineering. So I did my master's and PhD from Purdue University. And then I started working in the US in the industry. I was working at a company called Cummins. I think I'm sure both participants in both countries would be familiar with what Cummins is. In the US, they are famous for building engines for all the trucks that you see on the highway. And in India, they are famous for building gensets. I mean, they build other equipment as well, but that's what they're famous for backup generators. Then I started I worked there as a controls engineer. Hi. Yeah, sorry, there was some disturbance. Request you to please be muted. So I worked there as a controls engineer working on improving fuel efficiency as well as emission reduction techniques for these engines. After that, I worked as a research scientist and project manager at Siemens. So that's where I got to know both, and I worked in the area of robotics and how you can use AI and control techniques to make them more flexible and agile. And my focus was on utilizing AI techniques for manufacturing applications. So you can teach the robot to do different things like picking heavy objects, moving them in very precise manner, and so on. And I have some present videos about that as well, but I think I'll focus on agriculture today. Uh, after During the COVID period, my wife and I we decided to move back to India. So we joined a very fledgling university, just starting up, called Plaksha University. So we are located in Mohali. Our university is now 3 years old. So our first batch is going to graduate in the coming year. Um, and within Plaksha, I lead the robotics department here. So we don't have traditional departments like electrical and mechanical. So we offer UG programs in four majors: computer science and AI, data science, economics and business, biological systems, and robotics and cyber physical systems. So I lead the robotics and cyber physical systems major here at Plaksha. And I'm also the director for Center for Sustainable and Precision Agriculture. And my work at Plaksha is on drones and how you can utilize drones to give advisories to farmers, make them more productive. And I'll talk a little bit about what are some of the things that you can do in the area of agriculture, right? So I'm sure a lot of technology development has happened in the world, right? We engineers have developed a lot of technology, but not a lot of it has actually percolated to the people on the ground, right? While there are agricultural tools and equipments that people use in India, most of the latest technologies, it takes a very long time for them to come to the agriculture area, right? And that is what we at our center are trying to do. We are within our center, we have people working in the area of smart sensors, drones. We work on remote sensing and geospatial technologies, and then robotics, and we bring it all together and try to help our farmers, right? Um, I'm sure many of you would be familiar with agricultural situations, but um, can you guess how much water it takes to grow, maybe say get 1 kg of rice, for instance, right? So it takes about 4,000 liters of water to make just 1 kg of rice. Similarly, I deal a lot with sugarcane. It takes every acre of sugarcane requires 1 million liters of water. Right? The state that I come from, Punjab, has severe water shortage because of excessive production of paddy in the area, and the groundwater levels are essentially at I think 1,400 feet, right? So at this point, you are not pumping water from the ground. You are essentially mining water because you have to dig so deep to get water that the situation is really uh, really serious in the area of Punjab, right? And it's not that Punjab is very unique in this area. This problem exists in many states in India, right? So we are using excessive water. We are putting excessive amounts of fertilizers, which is polluting our water bodies, our underground water, our fields, our crops. And all of this will have an impact not just on the farmers, but on all of us, right? Because we ultimately eat all the food. I visit many farmers in Punjab, and they say that they grow food in two plots, right? There's a small plot where they grow food for themselves, which is which is more organic and probably healthy, and there's the other part which is sold to all of us, right? So it is, and it's we need to make these things uh, right. It's not just sufficient to blame the farmers, right? That you cannot tell them to not use fertilizers. You have to give them some solutions which can then help them out, right? So that is where our work has been. We collaborate. We try to bring in a lot of the new developments that have happened recently in the area of robotics, machine learning, drones, sensors, and we biotechnology, and we bring it all together and try to develop solutions for farmers, one crop at a time. Where for the past 2 years, we have been working in the area of sugarcane. So I'll tell you a little bit about two technologies that we have come up with. So one is related to measuring what is the sweetness of cane, right? So this allows the farmers to harvest the crop at the right time, and you can get up to 30% extra yield through that. And this device is actually 100 times cheaper than what is there in the market. And we are now doing a R&D on another version of the device, which will be essentially available at throwaway prices. So essentially you get a small strip for 100 rupees, and you can test whether your crop is right or not. Similarly, we work a lot in drone area, right? And I'll focus a little bit upon what are some of the things. So we need people to contribute to this, right? It's not just agricultural scientists, or it's not the responsibility of just agricultural scientists to participate in this area. We need computer scientists, we need machine learning engineers, we need roboticists, we need electrical engineers, mechanical engineers. All of us have to work together and solve this grand challenge, right? Because it is impacting all of us, right? You cannot hide behind this fact. Stubble burning is a big problem in the state of Punjab. We and the state of Delhi, right? That faces it the most, right? So in this interconnected world, we cannot ignore these problems. So that's kind of my thought to you, that while we see that this is a challenge, I also feel that this challenge also brings an opportunity, right? So sugar industry is just one crop, right? It's a 80,000 crore industry, right? If you can, through your efforts, improve productivity in this area, you can earn a lot of money, right? So this is just one crop, and India has so many crops. So a lot of entrepreneurial opportunities are also there. In fact, many startups are working in this area. So I would invite and encourage all of you to actually come participate in it. This will have huge impact in sustainability, not just in India. These solutions are required all over the world. So this is my this is my call to all of the budding scientists and engineers, and to come and participate with in this area and work towards us with us. All right. I'll just maybe show some. These are some of our drone flights that we do with sugarcane farmers in UP. This is so it's a lot of fun as well. You get to visit farms and meet real people, right? We do work with satellites, with drones, right? Specifically, we work with what are called as multispectral satellites. So this is kind of how a farm looks, right, from different resolutions. So this is from a satellite called Sentinel. This is about 100 square kilometer area near a sugar mill. So this is the mill, and these are about 10,000 farms around the mill, right? This is the same image, but from a different satellite, which has a higher resolution. So this is at 3 meters per pixel. This is drone, right? So drone gives you centimeter level accuracy. So every pixel on your image is 1 centimeter. Yeah, right. And there are some innovations that are developments that are happening in Israel, where they are looking at doing ultra high resolution imagery. So you can now look at individual insects on the leaves, right? So all of this gets you a huge amount of data, right? So this then becomes a big data problem, right? Can you use your AI algorithms to actually sort through all of this data, right? Google has petabytes of satellite imagery, right? Once you go to drone imagery, that it goes into exabytes, because your resolution, every time you 10x your resolution, your data goes up by 100x, right? Um, so these are kind of we are working with computer scientists to develop what are called as geospatial foundation models. So just like you have ChatGPT, right? ChatGPT is a language foundation model. So it works. It takes in the internet, right, and it then understands it through its algorithm, and then it kind of digests it and then recreates things for you, right? So that is what essentially ChatGPT, right? We are trying to build geospatial foundation model. So can we take in all of this satellite data, right, that is already available? Satellites have been observing Earth since 1976, when US launched its Landsat program. So can we take all of this satellite data, all of the drone data from the sensors, and build what are called as agricultural foundation models? So that is a big initiative that we have. Many of you may be aware that India has launched a new foundation model initiative. So we are also part of this initiative. All right, so I'm a little bit over time, so I'll probably skip a little through. But this is what crops look like, fields look like. So this is a paddy field from a drone. right? So you can, it has just been planted, so there's a lot of water there, and there are these small dots that you see. Each of them is a paddy sapling, right? So then you can do some image analysis on it and then figure out where there is excess water, where there's less water, and then you can give advisories to the farmer, because one of the biggest things that a farmer can do to improve its productivity is to laser level the field, right? Because if your fields are not leveled, then some areas have excess water, some areas have less water, and both of these things are not right for the crops, right? So you lose productivity in both scenarios. So those are things that we try to help and advise farmers about. It loses 15% productivity just because your fields are not leveled, right? And farmers in India are especially paddy farmers. They are quite poor, and I mean, the net profit that you get after growing 1 acre of paddy, right? Paddy is a 3-month crop, is about 20,000 rupees, right? So that is not an aspirational job, right? Who would want to work? I mean, you would get better money washing dishes or doing housework, right? So that's why no one in the youth, right? They want to do agriculture. So we are trying to see how we can increase the productivity of the farmer so that we can make agriculture aspirational again. Right? These days, these slogans are very popular. So anyway, so that's a little bit about what I do, and this is my call to inspire all of you to work in this area with me. Thank you.
Thank you so much, Shashank. That was really, really good information. We're all learning so much and very much inspired. Next, we have a wonderful Q&A session, which is going to be moderated by Manish Nair and Sindhu Suresh.
Yeah, thanks everyone. I know all of you, but I was really great to hear what you guys are doing and how it is impacting the world today. I feel like we had some general questions, but it seems like we have plenty of questions in the chat. If any one of you want to unmute and ask the question directly, please go ahead, but address the panelist whom you are going to ask. Otherwise, me and Manish will read the questions from the chat. Anyone wants to go and unmute? If not, I will ask the first question to you, Shashank, because you finished it. I mean, this is really interesting to know about what's happening on the agriculture field, but knowing about the farmers of India and the struggle they were going through in the last 1 year, how do you make sure they will adopt this technology? And most of them may not be tech savvy. And how will we help them to use these advanced technologies from a cost perspective, from a technology awareness perspective?
Right. So there's many layers to it. So when you say farmers are not tech savvy, everyone these days has a smartphone and a WhatsApp. So
I'm
they are
just
not
saying about my father.
These days, all farmers have WhatsApp and they can watch they can watch videos. Um, so, but the goal is from farmers' perspective, they don't really care about technology, right? It is an enabler for them to do the job which is so typically the way we work with is we work with agriculture universities. They have been working with the farmers for decades, and that is what builds trust, right? So whenever we have some new technologies, we work with the agricultural universities. We do small pilots first with them, make sure it is ready to be rolled out on the field, and then we roll it out to the farmers. Secondly, we work with so especially in the area of sugar mills, sugar mills themselves are actually invested in success of the farmers, because a success of the farmer will mean more crop for them to process, more productivity. So they are themselves interested in seeing how can we make their farms productive, and through them, that is again a small channel through which while they also don't care about technology, they care if we can show productivity improvement. So that is, I think, the way we have been
With it.
trying to. But education is a big piece in it, and we need support there. Yes.
Thanks, Shashank.
Sindhu, I just want to add a point to this.
Okay, go ahead.
Can I?
Yeah, sure. It's all about discussion now. Just go ahead, Praveen.
When the mobile phone revolution happened in India, right? See, it was one point of time. This was actually only because even you have to make a call, even pay even for receiving money. So there was a study which is done in ISO. I think it is open white document which is available there. The mobile technology has been used by the fishermen of Kerala, especially from Trivandrum to Alappi, I mean Ernakulam, the entire coastal belt. So they were able to use the mobile phones and then just make sure that their fishes are being sold at a better price, and which one lot of the people got the type of fish and where the market is. So they were able to really understand that, and then they were able to sell it. So obviously, the satellite technology is going to help in lot many ways for the farmers. Like ISRO has actually a plan with supporting details in the sense for the satellite data which they measure. I think at 5 meter resolution, which may not be suitable, but it is free. And then anything lower than that, I think you can get on a reasonable price. So that is actually came out of the space policy of Government of India in 2023. So this is going to help people out in a lot of ways. And if you look at the Farmers Act of the present government, at certain point of time, they were actually building up a lot of the godowns. That is where one of the major problems in India, because these are perishable goods. So rather than getting the productivity, you need to make sure that you have the godowns, and then necessity where exactly the demand is there, you need to supply it over there. So again, at that point of time, our what Shashank was talking about is going to have greater impact. So there are a lot of people actively working on this now.
Yeah, of course. There's no dearth of problems you have. So yeah.
Okay, so Manish, you want to take the next question? Or if anybody else want to unmute, please do unmute and ask.
Sure. Thank you, Sindhu. There are a lot of questions, and I was trying to categorize into different buckets. But one question that I found interesting, and probably this for Noorie, that the question is around the data, right? So how are you thinking, or how are you looking at modeling the various carbon footprint related data? And because there are situations where you do not have a lot of data, right? So how do you handle such situations for various AI modeling projects where you want to solve a particular problem, and you're looking at your past data, you have patterns, don't have patterns. So what are the challenges that you or as an industry you're facing, and how are you thinking about overcoming those challenges? Basically, the question is around AI modeling using the existing available data.
Yeah, it's a really good question. And as we are moving towards using this data for decision making, we have to be very confident about the source of this data, right? So we are in the process. The 1 year I've been here at HPE, we have started. The program was started just before I joined, but we started building a product carbon footprint model for every single product that HPE has sold since 2020. 2020 is our baseline year. We want to measure everything against. And it's a huge task. I can't even imagine a company like Siemens doing this, because HPE makes maybe one type of products, right? Siemens makes everything from large trains, to medical devices, to building controls. So making sure that we have accurate data for every single product that we're making, the manufacturing data, the material data, end of use data. It's very hard. What we are trying to do is start from a bill of material of every single product that we are making, looking at what it needs to be assembled. The biggest challenge is to get the data of the components that come from our suppliers, right? Because we don't have any control over that data. We can only ask, we can do our part of verification, but we are not present at the factories where these components are manufactured. So we have to rely a lot on literature, on research that's being done. We are working with a few companies that do tear downs of products. So literally tear down every single component of products that are in the market to go to material level to see what components are made up of a server, for example. And then we have to rely on some attribute level modeling, right? So SSD that is 24 GB versus SSD that is 1 terabyte, right? Is there a linear slope of carbon footprint for the 24 GB to 1 TB, right? How can we model this more accurately? And it all comes with additional data. So we have to sometimes forget that we are competitors with companies like Dell or others and collaborate on things like that. We have the same suppliers. How do we go to them to make sure the data is accurate so we can measure it and then report and finally work on reduction? So I hope that I answered your question.
Yes, you did. Thank you. Very insightful. And I will let others ask questions as well. Unmute yourself and ask.
Yeah,
I had
I
a
think, yeah,
um,
go ahead. I can't see. Who is that? Can you just say the name and then go ahead, please?
Hi, this is Jasmine.
Hi, Jasmine, go ahead.
I heard one of the speakers comment about a relationship with physics and quantum computing. Can you elaborate more on where you see them relating and what you think is what people should study to prepare for the quantum revolution?
Yeah, sure. So I think I was talking about that. Before I answer, I want to say that I am a power grid expert and I just learned about quantum so that I can apply for the optimization in the power grid. The way I learned that quantum computing is based on quantum physics, which is basically quantum mechanics. And quantum mechanics basically tells us that qubit, which is different than bit that we use in the regular computing, qubit depends on superposition, which means that qubit can represent itself in multiple states, and it is entanglement, which means it can be correlated even with being far apart. Also, quantum computing tells us that qubit is not bit, like 0 and 1, like a classical bits, because it can behave like a waves and particles. So everything that quantum computing is doing is actually based on quantum mechanics, and there's a lot of deep principle and thoughts in quantum mechanics. Starting from Heisenberg uncertainty principle, so that need to be studied and analyzed. It is it's still an open big problem to find a stable qubit using materials. And that's why we, at least like a power grid, we are not using actual quantum computing, but we are using resources available at IBM or any other provider that I work with, like D-Wave and others. But a lot of work that we want to do in the power grid is based on the quantum simulation using the quantum math. Because the stability of the qubit is still a physics problem that need to be solved. Hopefully that answers your question.
It did. Thank you.
It's like a different problem, right, Anurag? We are trying to make everything energy efficient and bringing quantum computing data center. Then one way you're increasing the need for power while we are saying go to all this advanced AI. So
Yeah.
interesting problem to solve.
Although I think that with quantum computing, it will be much more efficient because we will be able to do much
Parallel.
faster computing
Yeah.
with the quantum computing principles. So it might be we need to do analysis once we can get to the point. Right now, we are not at the point that we can solve a large scale problem in quantum computing using real one. Once we are there, then it should be much more efficient compared to the classical computing.
Yeah. Thanks, Anurag. I have the one last question. This is for Praveen. Praveen, the question is really, how good is India's manufacturing ecosystem for supporting aircraft system development when compared to countries like US, France? And the next part is, what is our expectation? Is it a SpaceX program which we are envisioning for India?
Okay, thanks for the question. Yeah, it's true. Our manufacturing sector was not performing up to the expectations, but the recent times there is a lot of emphasis by the government on manufacturing. And I can proudly say that some of the best manufacturing setups theoretically we have in India now, because if you look at General Electric has an advanced 3D printing facility which they started over there in Pune. So the entire gearboxes for almost all the Toyota vehicles actually comes from Mysore across the globe. So the manufacturing things were really bad, but it is actually keeping up to the space. So the present government's the motto right now is, earlier it was made in Bharat, make in Bharat, but now it is not make in Bharat, it is make in Bharat for the world. So it make for the world. So there are a lot of I think the Apple they have made, I think, one iPhones now they are coming from Gujarat from India. So there are a lot of activities on manufacturing sector going on there, especially in the space sector, which I can talk about us. If you look at the Raptor engine of the SpaceX, which is a fully 3D printed one, and what we have on a smaller scale, not at the capacity of the Raptor, but if you look at the Agni-Cool's liquid engine, that is also fully 3D printed, and that has happened in-house in India. So India is building up manufacturing stuff very fast. But by the way, when I am just talking about the space economy, I'm not just talking about the rocketry part alone. If you look at the rocketry part of the space economy, it is just 1% of the total, the value of the economy. The major part of the economy, around 36% of the price money comes from the satellite services. So the major chunk of the money is from services rather than using the data of the satellites and stuff like that, rather than on sending rocket or making rocket. So that's what my stuff is. But yeah, the satellite thing, yes, there are good manufacturing facilities coming up. To my knowledge, there are something around. Yeah, please. So there is pretty much a good amount of space startups which is now there in India. I hope I answered the question. So.
Yeah, Praveen, can I ask a follow-up question on that? I mean,
Yeah, sure.
The private enterprise involvement. What is government's vision now? Like, are they going to allow the full-fledged development, or it's only basically provide components, manufacture components and supply it to ISR or other space government agencies? I mean, will they allow something like SpaceX to be a private enterprise, to be a SpaceX or similar companies who can do the whole venture on their own?
Exactly. That is what I said. Actually, Agnikul actually makes rockets, fully functional rockets, which was a part of time, it was the monopoly of ISRO. And the Government of India Space Policy 2023 is actually says ISRO's roles are not going to be on satellite nor on launch services. The launch is going to be completely given to private parties. Just give an example, the PSLV, which was one of the workers of ISRO, is no more going to be made by ISRO. That is going to be taken over by LNT. So National Tubro is going to make the launch PSLV for the Government of India, and they are going to do the launching. There was another satellite launcher which is fully developed by ISRO, which is a small scale rocket launcher, basically for the small satellite operations, because that is what is predicted to be from a launch business that has the ISRO's website. They have actually called for people for quotation who wants to make and build. So the technology developed by SRO is going to be handed over to the private parties for doing completely, not just part, as a whole. I hope I answered.
Yeah, okay. Yeah, that is what I was going to ask. Like, so the ISRO is going to give the technology also to the private enterprise. I mean, they're not going
Exactly.
to. Okay.
Yeah. And the testing facility, the entire ISRO labs are going to be open to private people. If you basically have a component and you want to test it, you are always welcome to do it at the, through NISCL UK, you are always welcome to do it at ISRO.
Okay. Thank you.
I think we have a lot of questions here. We will be collecting the questions and sending to the panelists, and we will get back to you. Whoever who put the question, if you really, I don't know, some of them we don't know the email ID, so you have to let us know. In course of time, Pooja, you asked a question about the high schoolers and college going kids, and this is the right moment for us to announce the design contest. So Jiman, can you please bring up that flyer? The PowerPoint for that contest creator. Hello, Sojman?
One second, I'm not sharing. Yeah.
Okay, I just thought I am on mute. Okay.
Are you able to see it? Okay.
Yes, I can see it. So for the high schoolers and the college students and young professionals, and I know 3 of the panelists over here are professors, we are so excited and delighted to announce Concept Creator, which is part of our Engineering Week culmination. This is a global contest. So it's more information about the contest will be announced on March 1st, 2025. So you have the, this is really like you can create a design. It doesn't have to be a working prototype. It can be in any field. Like there are 3 fields basically, which we will announce on March 1st. And if you feel like you want to invent something which is out of these 3 fields, go ahead and do that, because there is a form will have an open question for that. So this actually segue into Pooja's question. Yes, this is an opportunity for high schoolers and college students, and it's a global competition. So whoever who is interested and who is thrilled to do this, we welcome all of you to participate in it, and stay tuned for that event. March 1st, we will be sending out the communication, and it will be spread through LinkedIn and all other social media like what we did for this event. Anything else I missed, Nina, or are we good here?
Sindhu, we are good.
Okay. So with this, I feel like our technical section will come to an end, and I will hand it over to Sojimon for word of thanks.
Yeah. So we really had a power-packed program today to celebrate the Engineers Week. I know we were short on time. We had a lot of speakers, a lot of things to discuss, but in our short time, whatever we could do, I think we have done enough. I mean, at least like we gave some introduction to many topics. So it was I would think that it was an incredibly informative and enriching experience for all of us here. So on behalf of KEAN, I would like to extend our sincere appreciation and gratitude to our esteemed guest speakers, Mr. Praveen Krishna, Mr. Anurag Srivastava, Ms. Noorie Rajvanshi, and Mr. Zishock Kim. Thank you for sharing your wisdom and expertise with us. Your insights were truly enlightening, and we deeply appreciate your generosity in sharing your experiences. And a special thanks to our Student Affairs Chair, Sindhu Suresh, for coordinating this event, working closely with our speakers, and selecting such relevant topics to celebrate the Engineers Week. KEAN truly values the leadership and dedication in organizing these programs year after year. I would also like to express my sincere gratitude to our KEAN President, Nina Sudhir, for your unwavering efforts in making this event a success, coordinating and following up, and ensuring everything came together seamlessly. Thank you, Sajida and Manesh, for being the moderators for this program and all your other supports. Sobi for all the behind-the-scenes efforts, Philippos Chetan for the news coverage, Mary for your support, Jacob Chetan, Biju, Jills, and rest of the committee for your teamwork and coordination. And we are equally grateful to all the engineers joined today. Thank you for your participation and engagement. I think we had around 60 participants at one point of time. So your thoughtful questions and discussions made this webinar a really valuable experience for all of us. Once again, we extend our deepest gratitude to our guest speakers for sharing your knowledge with us. We look forward to continue to create meaningful learning opportunities for all our members throughout the year. And thank you for being part of this webinar, and we wish you all the best in all your future endeavors. Thank you. Sajida, over to you.
Yeah, I think with that, we can wrap it up. Thank you all for joining. Have a great rest of your day.
Yeah. Thanks, everyone.
Thank you.
Thank you.
Thank you.
Thank you.
Thanks. Bye.
So, Jiman, we can close the Zoom, right?
Sorry, I was talking on mute. I'll copy all these questions.
Okay, yeah.
Otherwise, we'll lose it.
Yeah, I already did it in a Word, but if you can, I think it will save in Zoom if like
No, that
we can send it to the panelists and get their answers and maybe post it in KEAN website as part of this webinar so people can go there and see the answers.
Okay. Okay, I will end it now.
Okay, thanks, Sojiman. Thanks, everyone. Bye.
Thank you. Bye.
Yeah.